In this video, we will discuss about cousins in binary tree 2. Given the root of a binary tree, replace the value of each node in the tree with the sum of all its cousin values. Two nodes of a binary tree are cousins if they have the same depth with different parents. Return the root of the modified tree. Note that the depth of a node is the number of edges in the path from the root node to it. So what they are saying is that in the question, we are given the root of a binary tree. We need to replace each node of this binary tree with the sum of its cousins values, and then we need to return the same root again. So first, let's understand three terms related to binary tree which will help us in solving this problem. So the first is levels, second is siblings, and the third is cousins. So now what are levels? So this is one level, this is one level, and this is one level. So basically all the nodes which have same number of edges from the root node, they are at the same level, and whatever is the number of nodes that they have from the root node, that is their level. So if you see for this node, this is the root node itself, right? So for this, there are no edges between the root node and this node. So this is your level 0, right? Then if you see for these two nodes, so they are having one edges from the root node. So their level is 1. Then for these nodes, they are having two edges from the root node. So these are at level 2. So these are known as the levels. Now next are siblings. So siblings are the nodes that have same parent, right? So if you see here, this 1 and 10, both of their parents is 4, then that means these two are siblings of each other. Similarly, for this 4 and 9, 5 is the parent, so these two are siblings of each other. Then next is cousins. So what are cousins? Cousins are the nodes which are at the same level, but they have different parents, right? The nodes that are at the same level but have different parents. So for example, if you see in this node 1 and node 7, both are at the same level, which is level 2, right? But their parents are different. For this one, the parent is 4, and for this 7, the parent is 9. Then that means these two are cousins, right? And then similarly, this 10 and 7, both are at the same level too, and their parent is also different. So these two are also cousins of each other, right? Now, what the question is asking us to do is that in this binary tree, you need to replace every node's value with the sum of its cousins' values, right? With the sum of these cousins' values. So now let's remove this. So now let's see what will our binary tree look like when we replace all the nodes with their cousin nodes values. So now for this node 5, it is the root node. It is not having any siblings, right? Root node won't have any siblings. So for this, the sum will be 0. Then coming towards 4, at this level, there are only two nodes, which is 4 and 9, and they are siblings of each other. We do not have any cousin. So for these two also, the value will be 0. Then coming towards this node 1, what are its cousins? Only 7, right? So 1 will be replaced with 7. Then for this 10 also, the only cousin is 7. So this 10 will also be replaced with 7. Now for this 7, 1 and 10 both are the cousins. So what is their sum? That is 11. Then that means 7 will be replaced with 11. So this is what we need to achieve, right? So now let's see the intuition. How are we going to do this? So when you do the level order traversal of a binary tree, you have the access to all the nodes at a particular level, right? So can you somehow leverage that property for finding out this binary tree? So let's suppose if I am at this node 1, how do I know its cousins values? Because cousins are this, and I have not come to this node yet. So I don't know what I should replace this one with, right? So we will have to think of something else. So let's suppose we have one more node here, which is 2, right? In that case, what will happen is that this 7 will be replaced by 9, 10 will also be replaced by 9, and this 2 will have 11, right? So if you are at this level, right? If you are at this level, then for these two sibling nodes, they will be replaced with the same value, which is their cousin sum, right? But we don't know what is the cousin sum. But what we know is that this node's value is 1 and this node's value is 10, right? So can I use this information somehow to identify the cousin sum at this particular point itself? So let us suppose that I have the sum of all these nodes beforehand, right? What it will be? 1 plus 10, 11, 11 plus 2, 13, and 13 plus 7, 20. So their sum will be 20, right? So let's suppose I have this sum beforehand. So then I have 20, and then I can do the sum of these two nodes which are siblings, which will be 11, right? Now using these two informations, can I find out what will be the cousin sums for this node? So 20 was the sum of all these nodes and 11 is the sum of these two sibling nodes. So if I do the difference of these two, will I be able to get the sum of all the cousin nodes, right? So what we are saying is that the cousins sum will be equals to level sum minus sibling sum, right? So the level sum was 20 and the sibling sum is 11. So 20 minus 11 is 9, and that is what the number with which we had to update these nodes, that is 9. So now what we'll do is that we will calculate the level sum for all these nodes beforehand, right? So it will be, for the first level, it will be 5. For the second level, it will be 4 plus 9, that is 13. And for the third level, it will be 20, right? So this information will keep beforehand by doing level order traversal of the tree. Now we will have to do another level order traversal of our binary tree to update the nodes values. And at that time, what can I do is that when I am at this node 4, I know that its left and right childs are 1 and 10. I can do their sum, which will be 11. And I know what will be the level of this 4. Then I can simply do level plus 1, which will give me the next level's sum. So I will have next level sums, I will have the siblings sum, I can do their difference, and I can update the value of these two nodes. And after updating the value of these two nodes, then we will insert it in our queue for the next level traversal, right? So this node 1 and node 10 will be replaced with 20 minus 11, that is 9. So inside our queue, instead of 1 and 10 node, we will be having 9 and 9 node, right? So now here the problem is that we had to perform the level order traversal of our binary tree 2 times. So can we optimize it somehow? Can we try to do all these stuff in one level order traversal itself? So first level order traversal was giving me the sum of all the levels. So what if I do only one traversal, and in that traversal itself, on the fly, I calculate the sum of a level and update the node values as well? So that how can we do? That we'll see. So let's remove this. So you know when you are at this level, then inside your queue, you will be having node 4 and node 9, right? And then you will run a loop 2 times. In the first iteration, you will get node 4 and you will access its left and right child and you will insert it in your queue. And then in the second iteration, you will access the node 9 and then you will have its access to left and right node and then you will insert it in the queue. That's how we perform level order traversal, right? So meaning when I am at a particular level, I will be accessing all the nodes in the next level, right, for inserting them in the queue, right? When I was at 4, I was accessing 1 and 10. When I was at 9, I was accessing 2 and 7. So when I am doing any stuff for this particular level, I can calculate the sum of the next level. So whenever you are inserting these nodes in the queue, you can take their sum in a variable, right? So then when you will come at this level, you will already have this level's sum stored in that variable, right? So when you are running for 4, let's suppose there is a variable level sum. So in that you will add 4's left child if it is present, so it will be 1, plus 4's right child if it is present, so plus 10. And then in the next iteration you will have node 9. So if 9's left node is there, then plus 2. If 9's right node is also there, then plus 7. So this will give you 20, right? So at this level itself, you got the level sum for the next level, which is 20, right? So now when you will come at this level, you will already have the level sum pre-calculated. The only thing that you need is sibling sum, right? Now how are we going to identify the sibling sum? So when you will be at this node 1, you don't know what will be its sibling, because at a time we are considering one node, right? So then that means before coming to these nodes, I should know their sibling sum as well, right? Because in the previous approach also, what we were doing, that when we were at node 4, at that time itself we were updating node 1 and node 10, right? So here also we will have to think of something that we can get the sibling sum of these two nodes before we arrive at these two nodes, right? So for that, what we can do is, see, the sum of these two siblings is 11, right? So for this node also I need 11, and for this node also I need 11. But in these two, the sum will be 9, right? So for this node I need 9, and for this node I need 9, right? So how will you be able to access that? So what I'm saying is that when you are at this level, you insert its left and right child into the queue, right? So instead of inserting these left and right childs as is, you update their values with the sibling sum and then insert it into the queue, right? So basically what I'm saying is, if this is your queue, right? So when you are at this node 4, you will see whether its left child exists or not. So here it exists. What is its value? 1. So you push the node 1 here in normal level order traversal, right? And then right child is also present, so you insert 10 here. Now, before inserting these two nodes in the queue, replace the values of these two nodes with their siblings sum. Add this 4, find out what is the sum of the left child and the right child if they exist, right? So it will be 1 plus 10, that is 11. And then replace the value of these two nodes with 11 and then insert it into the queue. So in that case, you will have 11 and 11, right? So when you will come at 9, then the sibling sums will be 2 plus 7, which is 9. So you will replace these two nodes values with 9, and then inside the queue you will insert 9 and 9, which is these two nodes, right? And in some other variable, that is level sum, you would be having 20 as the level sum of this particular level, right? So now when you will come at this level and you will come at this particular node, you know that this is the level sum. You know that whatever is the value of this node is its sibling sum. So you can apply this formula, you can get the cousin's sum, and then you can update this particular node with the cousin's sum, right? So that will give you 20 minus 11, which is 9. So whatever is this particular node, you will update its value to 9. So that's what you need to do. So now all of these will be updated with 9, 9, 11, 11. And then again, if there would have been any childs, then you would calculate their sibling sum and then you would replace these values with the sibling sum and then insert into the queue, right? So this is the approach that we are going to follow for finding out the cousin sums. So let's code it out. Looking at the code, you will be able to understand better. So first of all, we'll check that if our root is a null pointer, then return root, return the null pointer itself. Now what we need is we need a queue for doing the level order traversal. So this will store tree node. So let's name it queue. Now inside this queue, we will push the root node, right? Now we are going to have the level sum, right? At every level, we will be calculating the sum of the next level, right? So for storing that, we need some variable, right? So we'll create a variable level sum, right? And initially it will store the value of root, right? Now after this, we will start our level order traversal. So while our queue is not empty, what we'll do, we'll take the size of the queue. So it will be queue dot size. Then we will run a loop which will start from 0 and go till size, and then we'll do I plus plus, right? Now inside this, what you will do, you will access the front node from the queue. So it will be, let's name it node equals to queue dot front, right? And then you need to pop this, so queue dot pop. This node's value is to be updated with the sum of its cousin's value, right? Now through the approach that we discussed earlier, we said that the level at which this node is present, its sum will be stored in level sum, right? And when we had inserted this node inside our queue, we will update its value with its sibling sum before inserting, right? So for this particular node, level sum is present here and the sibling sum is the value of this node itself, right? So can I say that I will do node's value equals to level sum minus node's value, right? Because this is the level sum, this is the sibling sum. Their difference will give me the sum of cousin nodes so that I can add it in the nodes, right? So now I have updated it. Now I need to do things for the upcoming nodes, right? So what do I need? I want to calculate the level sum for the next level, right? So first of all, let's create a variable here, next level sum, which will be 0. Right. So this for loop will run for all the nodes which are present at the current level, and then you can access their left and right child and you can sum up their values. That will give you the next level sum, right? Now another thing that we wanted to do was that before inserting the left and right child of this node, we will update their values with the sibling sums, right? So we'll create a variable sibling sum and its initial value will be 0. Now if the node's left child is present, that means it is not equals to a null pointer, then in the sibling sum, we will add the value of node's left, right? And if node's right child is also there, that is also not a null pointer, then in the sibling sum, we will add the value of node's right also, right? So this will give you the sibling sum. Now, what we need to do is we need to update the value of the left and right node to this sibling sum before inserting, right? So again, we'll check that if the node's value is not a null pointer, then in that case, what you do, change the value of nodes left to sibling sum, right? And now you push it inside the queue, right? And the same thing we'll do for the right child also. So if the node's right is not a null pointer, then in that case, change the value of node's right to sibling sum and then push it inside the queue, right? So now once we have done this, we need to update our next level sum also, right? In the sibling sum, we are having the sum of both left and right node, right? So if in the next level sum, I add this sibling sum, right? Then for every node present at the current level, whatever are their sibling sums of its childs, that will be added in the next level sum, and you will be able to get the sum of the level which is next to this node in this variable, next level sum, right? Now, once this for loop finishes, we will update our level sum with the next level sum, right? And at the end, you can simply return your root. Now for the root node, what will happen is that initially we had pushed root node inside our queue as is, right? So in our example, the root node's value was 5, then that means the node that is present in our queue at the front is having the value as 5. Next, the level sum we took as the root's value. So root's value was 5, so in level sum also we have 5. So now when you will come inside here, in this node, what is the value? It is root node, right? So its value is 5. And in the level sum, what is the value? That is also root's value, so that is also 5. So here it will do 5 minus 5, which is 0, and it will update the node's value to 0. So for the root node, this is how it will update the value to 0. So I hope you got it. So let's run this now. So our test cases are accepted. Now let's submit this. So it got accepted. Thank you so much for watching. Please subscribe our channel.